Okay, good morning and welcome. The first thing we're going to talk about today is the perpendicular bisector theorem. And what that says is that if we have a line segment, let me get a little line segment up here. We have a line segment, and we have another line that bisects that line segment perpendicularly, like so, for a 90-degree angle. If it cuts this line segment perfectly in half, it bisects it because they're the same distance. It's a perpendicular bisector. What the theorem says is that we can take any point on this line, if it's a perpendicular bisector, say, so for example, a point right here, and that point is equidistant or equal distance to both endpoints of the segment. So this point right here is going to be the same distance to both endpoints. So this is 14, that's going to be 14. It's equidistance. And we can put a line from any point on that perpendicular bisector. If I lower the point a little bit, I still have the same scenario. These two lines now are going to be congruent or equidistant. I can even go down below and put a dot or a point lower on the perpendicular bisector, and it's still going to be equidistant to both endpoints. That dotted line wasn't that straight, but you get the idea here. So whatever the distance is on one, the distance is going to be the same on the other side because of the perpendicular bisector theorem. All right, the converse to that says, well, if these are equidistant, because the converse is like the reverse of it. So if I have a situation where I have a line segment all right, and these two lines are the same distance, say they're both 7. All right, the converse says, well, if those are equidistant, then this is a perpendicular bisector, which means it's 90 degrees. It also means these two segments are congruent to each other. So that's the converse of it. And that's your perpendicular bisector. Let's do an example. Okay, so in your notes, we have to find what is the value of AD. Well, by definition, this line right here, AC, is a perpendicular bisector. We know that because it's 90 degrees, and both segments on the bottom are congruent. They're equidistant. So that means these two segments up here would also be equidistant because of the perpendicular bisector theorem. Well, if they're equidistant, that means they're equal to each other. So if I want to solve for the value of AD, I would simply take 6x minus 10, and I would set that equal to 3x plus 2. Now the geometry part's done. Now all we're doing is solving it algebraically. So I'd subtract 3x from both sides. It cancels out the 3x over there. I get 3x minus 10 equals 2. I want to move the 10 over. I got to add 10 to both sides. And as I run out of room, we'll rewrite it up here. That will give me 3x. As that part's canceled out, 3x equals 12. So if I divide both sides by 3, x is going to be 4. But it doesn't ask for x. It asks for the value of AD. So now that we know what the value of x is, we just plug it back in. We go up here, 3 times 4 plus 2, because x was 4. So we plug it in for the x value. We end up with 12 plus 2 equals 14. All right, so the value of AD was 14. All right, let's do a couple of U-triads. All right, so take your time, hit pause on the video, and solve this problem. It wants to know the value of W, Y. And when we come back, we'll go over it on the board. All right, hopefully you hit pause by now. So we have the same situation here. This is a perpendicular bisector. Both of these segments are congruent, which means both of these segments are also congruent. So we simply set those two equal to each other. 2n plus 7 is going to equal 5n minus 2. The geometry part's done. Now it's just algebra. If I subtract 2n from both sides, I end up with 7 equals 3n minus 2. Because I subtracted 2n from both sides. Now I'm going to add 2 to both sides. I'll get 9 equals 3n. Divide both sides by 3. N equals 3. If n equals 3, we plug it back into that little algebraic expression. So it'll be 2 times 3, plus 7. Because we went for wy. And then we would get n with 6 plus 7. And that's going to give us 13. So the distance there would be 13. All right, one more. How else can we see these? With that, oh, this one. All right, so what is the value of OL? So here we have a perpendicular bisector, which means both these bottom segments are the same. The two top segments are also congruent to each other. All right, so it wants to know the value of OL. It just wants to know the value of that little segment there. We also have another perpendicular bisector down here. So we have two perpendicular bisectors, which means these two segments right here are going to be congruent to each other. So if you think about it, if that segment's 14, what's the distance from N to L? That's right, it also would be 14. And then if that little line there bisects NL, half of NL would be 7. So OL would equal 7. All right, so that's perpendicular bisectors. Let's move on to angle bisectors and the angle bisector theorem. So the angle bisector theorem says that if we have an angle and we have come back here. So if we have an angle and we have a line or a ray that goes right through the middle, it's an angle bisector. All right, so basically if it bisects the big angle, both of these two smaller angles are going to be congruent to each other. They're going to be the same measure. So it cuts it perfectly in half. Well, what this says is any point on the angle bisector is going to be equidistant to the other two rays. So you have to draw them perpendicularly, though, because you have to draw a straight line from this point to the actual ray. So if I draw a line perpendicular, and I do the same thing on the other side. So because this is an angle bisector, it makes these two congruent. That in turn makes these two lines also congruent to each other. So for example, if both of these were, say, 40 degrees, because they're angle bisectors, that means these two segments would also be congruent or equidistant. So say if that was 10 units, that would also be, say, 10 units. But it has to be perpendicular to the other rays. Because obviously, if you just draw lines in different directions, it's not going to be equidistant. All right, let's do an example. All right, so for this one, it says, what is the value of KL? So we don't know the value of KL here. And it doesn't have the little tick marks on here to determine that they are congruent to each other. However, based on the angle bisector theorem, if these two angles are congruent, that means LJ is an angle bisector. That in turn would make these two segments equidistant or congruent with each other. All right, so if I want to find out the distance of KL and they're congruent, you just set them equal to each other. 2x plus 3 is going to equal the other side, 4x minus 11. All right, so I'm going to move all my variables to one side, all my constants to the other side. So let's subtract 2x from both sides. That cancels that part out. That gives me a 3 equals 2x minus 11. Now I'm going to move the 11 over by adding 11 to both sides. Remember, you always do the opposite of whatever it's telling you to do. So here it says subtract 11. If you want to move it, you're going to add 11. But whatever you do to one side, you have to do to the other side. So this gives me 14 equals 2x. If I divide both sides by 2, x is going to be 7. But I'm not solving for x, I'm solving for KL. So now I just need to go back up here, plug 7 into 2x plus 3, like so. 2 times 7, because that's the value of my x, plus 3. I get 14 plus 3. So the distance of KL is 17. That's that problem. All right, one more. We're going to do one more problem. All right, here we go. If h shot, now here we're given a diagram and we have to label. Because sometimes, that happens. All right, if hi is 7, let's change the color up. You know what? Let's use green because it's St. Patty's Day today. Happy St. Patty's Day, everyone. All right, so if hi is 7, and ij is also 7, all right, well, that means these two are congruent to each other. And we know right away if they're congruent, using the converse of the angle bisector theorem, means if they're equidistant, it means this is going to be an angle bisector. And the measure of HGI, h to the g to the I, is 25 degrees. What is the measure of IGF? IGF, well, if these two are congruent to each other, and then if that makes that an angle bisector, it means this would also be 25 degrees. So my answer for this one is 25 degrees. All right, next question. So let's clear out this information. So we got to relabel it. All right, so it says, if the measure of HGI is 57 degrees, and the measure, HGJ is 57. You got to be careful with that. HGJ, that's the big angle here. Okay, HGJ. So what it's saying is this big angle right here is 57 degrees. The whole big angle is 57. And the measure of IGJ, now we're back to one of the smaller angles right down here, is 28.5 degrees. And HI is 12.2. What is the value of IJ? So wants to know IJ out here. Put a little X in there. So wants to know that value. All right, we're not sure if this is an angle bisector yet. However, if I take my big angle and divide it by 2, and I get 28.5, then it means it's an angle bisector. So let's do that. Let's take the measure of the big angle, 57. If we divide that by 2, we are going to get 28.5 degrees. So that means that measure is 28.5, and that measure is also 28.5 degrees. So, since they're congruent, it's an angle bisector. And since that's an angle bisector, that means these two segments out here are also going to be equidistant or congruent. So that's 12.2. What do you think x is? That's right, it's also 12.2. All right, so if you guys have any questions, please ask me in class. Don't forget, we have tutoring every Thursday. What do you know? It is Thursday. Hope I'll see some of you guys in tutoring today. Take care.